Okay, in this screencast, we're going to look at the graphs of absolute value functions and reciprocal functions. We're moving into an area of transformations, graph transformations now. And before we get into translations and vertical and horizontal stretches, we're going to look at the transformation of taking a function and then looking at its absolute value, or taking the absolute value of that function. And also, we're going to look at what happens when you take the reciprocal of a function and what the effect of that is graphically. So in order to have a look at, firstly, absolute value functions, we're going to sketch this graph at y equals x cubed minus 4x, and we're going to mark in the x-intercept. So let's get to work on that. Is x and y axes. And in order to sketch this function, I imagine we'll want to see in factored form what it looks like. And so I can factorize to this function here. That's a whole lot more useful for me. I can see that I've got x-intercepts here and here, and it's going through the origin as well. So I'm going to be going through roughly like so. That's my cubic. That's not the point of this. I now want to see the absolute value function and what results when we take the absolute value of this function. So, okay, so now we're going to have a look at two absolute value transformations of this function. Firstly, in red, we're going to look at the absolute value of the whole thing. So what that entails is that we're going to take our function, and what does the absolute value of it mean? Well, it means take the outputs, take all the results, and make any negative results positive. So graphically, that means we're all positive here, so no problem, no change. Anything here below the x-axis, that's going to reflect up above the x-axis. So we're bouncing in this section. Now we're above, so we stay above, and anything below here now gets reflected above, and we just need to make sure we get our concavity right. Now I might have just bent that a little far, so I just need to do something like this. Okay, so this is part A, the absolute value of x cubed minus 4x. Just takes all my negative outputs and makes them positive. Now in part B, my green function, this is slightly different, isn't it? The absolute value of x, so we're now taking the absolute value at the input level. And what this means is that any negative value for x that we throw into this function, it immediately makes it positive. So anything positive again in this part, any positive x, there's no change. No change, no change, no change. Because it's going to get treated exactly the same way as my original function. Now, when x becomes negative, what happens? Well, the absolute value immediately makes it positive. So I'm just going to get a reflection in the y-axis now. This just gets reflected like so. So the green one, perhaps I can draw the green one again. It looks a little bit like this. We get the first part of this cubic in the positive for x is greater than 0, and then it just reflects. So that is, they're my two absolute value function transformations. Now let's have a look at what happens when we take the reciprocal of a function. Okay, we're going to have a look at what happens when you take the reciprocal of a function. So we'll start with this function here, y equals x squared minus 2x, and just as we did in the previous case, it's going to be easier for us when factorized. Whenever we're looking to sketch something, factored form is helpful, isn't it? So x minus 2, what does this tell us? That we have intercepts at the origin and at 2, and it's quadratic, it's a parabola. So my turning point is going to be halfway between 0 and 2. So my turning point is going to be down here at x equals 1. That's not very clever. So here somewhere, and so down comes my parabola. I just like to always make a little horizontal line so I don't make it too pointy. Just guides my parabola nicely through the curve. although that's still not great. 2 is here, 0 is here. The coordinates of my turning point, right, well, I know that x equals 1 here, so I can put 1 down, and y equals 1 minus 2, so I am at 1, negative 1 for my turning point. Great, okay. So that's the sketch of my quadratic. That's not a reciprocal. Now I want to look at the transformation that results from graphing the reciprocal function of this. So what that means is now, okay, so we're now sketching the reciprocal function y equals 1 over the square root of, x squared minus 2x. I should say at this point that we have sketched these functions. We've sketched absolute value functions. We're just having a closer look at them as a transformative type of function. So first thing we pick up here is we look for our asymptotes. We look for the important features, the key features, and then we put all the pieces together after that, don't we? So first up here, I think it would be prudent for us to mark in the points or the asymptotes, the values of x that this cannot entertain, this function cannot entertain. So x equals 0, always writing our asymptote equations in, and x equals 2. Okay, so then we're looking to acknowledge the behavior of this function in each of these 3 zones now. So let's go to the middle zone, because this is all important. And that is, so I've got my turning point here. I know what my turning point coordinates are. So remember my green is x squared minus 2x. So I'm now graphing 1 over this. So what's the reciprocal value for negative 1? What's the reciprocal of negative 1? Well, that's just negative 1 itself. So I know that my reciprocal is also going to go through this point, and it's going to form a turning point. But the turning point is going to be a maximum, or a local maximum in this case. As I get closer into 0 here, my values of the function are getting super large. So I'm doing something like this in this part of the curve, in this zone. Okay, if I now look each side of the middle zone now, and I look at this branch here, this is heading off to infinity. This is growing large without bound. So what happens to my reciprocal of ever increasing values? It's going towards 0. So this now means I need to acknowledge a horizontal asymptote, which is at y equals 0. So as my function gets larger, my reciprocal function gets smaller, and vice versa. As this green curve gets in super close to the 2 and becomes really small, I am now taking the reciprocal of a really small number, which is a really large number. So I have a branch here, and similarly over this side, I have a branch here. And that is my the sketch of my reciprocal function. Okay, we're going to go and have a look at exercise 2O and exercise 2P. So we'll have a look at those. We'll get some, in O we're looking at absolute value, and in P we're looking at 1 over function, reciprocal functions. Get some practice at those, and I'll see you next time.